Good morning, good afternoon, and good evening to all of you. So let's start with a introduction. So I am Manisha Biswas, and I work as a software developer at InSync Techfin Solutions Limited. And I am basically based out from India. And this is my first talk at the Global IoT DevFest, and I'm super excited. Let me start, and let me now just share my screen. And so this is exactly what I'll be talking about today. That is data analytics and artificial intelligence with tactical and strategical decision making. So tactical and strategical decision making is basically a part of reinforcement learning, and I'll be talking about it in brief today. So let's move ahead. This is something more about me. As I already told that I work as a software developer at InSync Techfin Solutions Limited. I'm an Intel software innovator, and I am Google Women Tech Makers Kolkata chapter lead. So apart from this, I'm an author too. I have very recently written a book with April's publication on reinforcement learning with TensorFlow, and I'm still working on my another book with artificial intelligence with bot framework. So let me just redirect you to the link. So here you can get the book. So now moving ahead to the most talked about thing nowadays, the data science. So now let us first understand what is data science. So as it says, data science is an interdisciplinary field about processes and systems to extract knowledge or insights from data in various forms, either structured or unstructured. So I think this particular definition might be too lengthy to understand. So let me just break it into keywords. So data science basically works on different kinds of processes, and from this processes we extract knowledge and data. And data can be either in two forms. One is structured or unstructured. So structured means it contains metadata, and unstructured means it does not contain metadata. Now let us understand how exactly the data science process works. So from the figure, we can say that first we have to collect the raw data, which may be again structured or unstructured, as I already stated. After that, we have to process the data, and then within the data set, there might be redundant or duplicate data. So we have to first clean the data set. And once the data set is clean, then it is ready for explanatory data analysis. And once it is ready for explanatory data analysis, then we can apply machine learning algorithm to create a data model. And then once it is done, then we can generate a report using any visualization tool, or we can create a data product. So finally, we have to make a decision from our analysis whether our data model is accurate or not. So this is exactly how the data science process works. So now let us understand how AI stack works. So I'll be explaining the whole picture with all the concepts in my slides further. So let us first understand what is artificial intelligence. So as it says, artificial intelligence refers to the broad category of computing where a system is capable enough to learn directly from data. And artificial intelligence forms the basis of instruction flow to work on a systematic way. So now let us understand what is machine learning. So machine learning is a subset of artificial intelligence, and it uses a lot of data sets. So machine learning is a way we apply to a program to perform a task, and with time the efficiency of that program increases. And if the efficiency of the program constantly increases with time, then we can say that our data model works perfect for us. So now let us understand what is deep learning so that we can have a comparative study of all these three. So when we are working with a lot of data and reached a computation tipping point, we apply deep learning in it. And in deep learning, we are usually using neural networks. So I can conclude from this that AI is the broader spectrum of all the machines, information flow, and units working together, whereas the subset of artificial intelligence is machine learning and deep learning. So moving ahead, uh, to understand how exactly the tactical decision making works, we have to first understand the concept of reinforcement learning. As I already told, that the tactical decision making is a part of reinforcement learning. So, reinforcement learning is another branch of AI which has its resemblance from machine learning. But machine learning works with dataset and reinforcement learning works with environment. So reinforcement learning is an approach through which some intelligent programs known as agents work along on a known or unknown environment to constantly adapt and learn based on given points. And these points might be positive or negative. And the positive points are known as rewards, whereas the negative points are considered as punishment. So now let's move ahead to the main core focus of our session, that is tactical decision making. So as I already told, it is a basis of applying artificial intelligence with the help of reinforcement learning. So tactical decision making is the way we take the next step, which should be an intelligent one, and this step is very essential for our output. So to understand better, let us take an example. Suppose we are in one state and we have to move to another state, and there are two options available for us to choose from. Then we will make the intelligent guess to reach the optimal output. And the intelligent guess is made by the function that we will implement. So this function is exactly which acts as tactical decision making. Moving ahead, now let us understand how to apply reinforcement learning. As I already stated the difference between the machine learning and the reinforcement learning. So machine learning differs as machine learning basically works with data sets, and reinforcement learning works with environments. So environment in reinforcement learning are real world scenarios which might be two-dimensional or three-dimensional environment simulated world or a game-based scenario. And the objective of reinforcement learning is to reach to a goal. So now let us understand the reinforcement learning cycle with the help of a robot. So here, as in the picture, you can see that there is an agent, there is an environment. So what basically is happening is that here the agent is the intelligent computer program that is constantly interacting with the environment. So the key concept of interaction would be the state it needs to go to and the action it takes to move to the next state. So when the action is taken for the optimal output, then reward is given. As you can see in the figure, get reward R. When it moves to the new state S dash with the optimal output, then you get a reward R. So now let us understand tactical decision making process with the help of an example. Let us take an example of a maze. So in a maze, the centralized concept is to keep moving always. And what should be the output? When we are taking an example of a maze, the output would be to clear the maze and to reach the end as quickly as possible. So from this example, we can say that our agent is the intelligent program, the environment is the maze, and the state is the place we are in now in the maze, and the action is what move we take to move to the next state, and the reward is point associated to reach a particular state. As I already told, the reward points might be positive, negative, or zero. So moving ahead, let us analyze the concept of maze in terms of tactical decision making. So the concept of maze is given to the agent firstly, and then there is task associated with the agent. What task is associated with the agent? The task associated with the agent is that the agent has to move from one state to the other state with the optimal output. So we apply reinforcement learning to it, and then the agent receives A-1 reinforcement for every move it makes from one state to another. And as I already told, there is a reward system in place for the agent when it moves from one state to another. So the reward predictions are being made iteratively, where we update the value of each state in a maze based on the value of the best subsequent state, and the intermediate reward is obtained. So this is called as update rule, which is exactly the tactical decision making. So moving forward, this is exactly how the reinforcement learning structure works. So from this, we can conclude the key points of consideration are: the reinforcement learning cycle works in interconnected manner, as there is a constant interaction between the agent and the environment, and there is distant communication between agent and environment. The distant communication happens with reward in the mind, and the object or the robot moves from one state to another, and action is taken to move from one state to another. So this is how exactly reinforcement learning process works, and it is same for all, and this concept is same for all the process. So moving ahead to reinforcement learning interaction. So as we can see from this figure, agent can be a learner as well as a decision maker. So when agent is a learner, and agent is a learner means there might be different non-deterministic part. When the agent starts training it, it starts to adapt and intelligently learn from the surroundings. And the agent can also be a decision maker. It is a decision maker because it tries to take an action which is a suitable path to get the maximum reward. As you can see from the picture, that the agent interacts with the environment, and when the agent starts interacting with the environment, it is able to choose an action and respond accordingly. So from then, new scenes are being created. These scenes help us to solve the reinforcement learning problem more effectively. So in return, we get a reward which is associated to the response. So now from this, we can conclude that the constant way of reinforcement learning process is based on decision making. And reinforcement learning works on trial and error basis, because it is very difficult to predict which action to take when it is in one state. And as I explained the maze problem, from there we can also conclude that maze problem itself, we see that to get the optimal path for the next move, we have to wait a lot of things. So it was always on the basis of state, action, and reward. So for the maze, also we have to compute and do probability to take this step for the change. So this concept is same for all reinforcement learning process. So we have gathered information about how reinforcement learning works. So it is basically combined with three things: SAR. So here A stands for state, A represents action, and R represents reward. So moving forward to our main focus area, let us know how we can apply tactical decision making. To apply tactical decision making in machine learning, we will have to use a technique called Q-learning to make the best possible move for the next step. Now, let us understand what is Q-learning. Q-learning is known as model-free reinforcement learning technique. And now let us know what is Q. So Q can be stated as a function which consists of two parameters, state S and action A, and together it can also be referred as Q table. When we are taking the two parameters state S and action A together, then we can call it as an Q table. So now let us understand what is a Q table. As I already told, Q table represents the value that an action A takes with the state S. So Q of SA is equal to immediate reward plus discounted reward. So now let us understand what is immediate reward and what is discounted reward. So immediate reward is the point given when it moves from state to another while doing an action, and discounted reward is the point given for the further future references. So how we can use a Q table? We generally come up with scenarios where we have to find out where we can utilize the Q table values or Q values. So Q is implemented in this process, and we are looking at what action we take when we are in state S, or which policy to implement when we are in state S. So we take the advantage of Q table to get the best result. So when we should use a Q table, we should use a Q table to search for the um, best Q value, the optimal output we want. So now what is Sarsa? Here A stands for state, A stands for action, R stands for reward, and S stands for next state, and A stands for next action. So Sarsa is known as own policy reinforcement learning, and own policy means we can see only our experiences. It accumulates updates of one or more steps and learns to update from its advantages. So what basically happens in Sarsa is that from current state, we choose an action and then get to the next state. And at next state, to choose another action, we use current state, current action with the next state and next action, and update all the values together in a Q table. So now let us understand how to update a Q table. As you can see from this figure that in a Q table, first we look for current action and current state. Then when we are updating a Q table, then we look for next state and next action. Then again, when we are updating a Q table, we combine all the values and then we update. So the best update would be when we are comparing all the values and then updating. So now the demo video. I have already made a video beforehand so that I can show the entire reinforcement learning and Unity process in one go. So let me start the video. Yes, here it goes. So before starting the video, it is a demo which I have made using Unity 2017 and reinforcement learning. So to run this demo, you need the prerequisites are Unity 2017, because this demo is only compatible with Unity 2017. As reinforcement learning is only compatible with Unity 2017, it will not work in other versions of Unity. So you would require Unity and you would require Anaconda command prompt. So I have both of them installed at my side. So now let's move ahead with the video. So here it is the GitHub link where you can get all the Unity RL agents for free. You can get all the informations and details over here. So now let's first move ahead to the main repository and we will download it. It is a zip file. And we have to extract it to a folder. Yes, so I have extracted it in the folder Unity R12. Then launch Unity 2017. Open the folder in Unity. Yes, here you can see 3 folders available. You have to open the Unity environment. Yes, so it would open in Unity. So here in the bottom left, you can see there is an assets folder. And below that, you can see the ML agent folder that we have opened up in Unity. So you have to go to examples, then you have to go to 3D ball. There you can see a scene. You just have to right click it and click open. The scene would be open in Unity. Now just go to edit, then project settings, Then select player. To update the player settings. Okay, now go to scene that you can see at top right, then Ball 3D Academy, then Ball 3D Brain. Select player and I'll just run this scene in Unity Game Engine. So this is the output. I will just show you this output in the Jupyter Notebook as well. So now to run this brain script with Jupyter Notebook, we have to go to brain section and we have to edit the brain type to external, because this will allow us to run this script in an external Jupyter Notebook environment. So once we are done with all the updates, we will just save the file so that we can compile and run it. We will go to save as scene. Yes, we'll go to save scene as, then I'll save it with my name, Manisha. Then I'll go to build settings and I'll click add open scenes. And I'll check the checkbox named Manisha, and then I'll check the checkbox of development build. Then I'll build the solution and I'll save it in the Python folder. It will generate an exe in the Python folder, which I can compile and run in Anaconda environment. So here in the Python folder, I'll be saving the exe. I'll use the same name, Manisha, and I'll save it. So it is building the player. So you can see here that Manisha exe is being saved in the Python folder. Now I'll just open up the Anaconda command prompt. So here, first you have to create an environment. I have an environment created at my site, so I will just activate it. I'll use the command activate TensorFlow GPU. TensorFlow GPU is the name of the environment I have created. So yes, it's activated. Now I'll just invoke the Jupyter Notebook using the following command. This will just open up the Jupyter Notebook in the browser. So you can see that the Jupyter Notebook is open up in the browser. So if you are using it for the first time, if you are connecting the Jupyter Notebook for the first time, you just have to copy and paste this URL in your browser, which is generated within token. You will just have to copy and paste it in the browser. So now I'll be going to desktop, then Unity R12, as I have extracted the folder in Unity R12. So now I'll go to ML Agents master folder and then I'll go to Python folder. Then I'll just select basics.ipynb. Here, what I have to do first is that I have to set the environment parameter. I have to set the environment parameter name. So I have to set it with the name of the Unity environment file that I want to launch. So the name was Manisha, So I'll just rename the environment name with Manisha, and then I'll just run each cell. So it starts with the first cell, load dependencies, and it will load all the dependencies required to run this program. It will load the NumPy and Unity agents and all. Then I'll run the next cell, which is set environment parameter, and you just have to rename the environment parameter over here with the name of the Unity environment file that you want to launch. So that was Manisha for me. Then I have to run the next cell, which is start the environment. So this will launch the Unity environment here in the Jupyter Notebook. You can see the number of observations per agent over here. You can see the state that I was talking about. You can see the actions that I was talking about. So you can see that the Unity environment is being invoked in the Jupyter Notebook. So now I'll run the next cell, which is examine the observation and state spaces. You can just see here, it shows the agent states. When I run the cell, examine the observation state spaces. Then I'll just run the next cell, which is take random actions in the environment, so that we can see the reward points. So you can see here the same output that I showed earlier in the Unity game engine. I'll just use a magnifier. Yes, you can see the development build, and you can see the same output over here. So now I will execute the next cell. So here you can see the rewards which I was talking about. As I already told, the reward may be 0, positive or negative. Here all the rewards are all positive values. So my build is successfully compiled and run. So I will now just close the environment as it's finished. So these are the steps using which you can run Unity program in a Jupyter Notebook. So I hope you enjoyed my session. Thank you all.